What is happening, meteorology students? This is Mr. Call with a few slides and some information on the greenhouse effect. I'm guessing you've heard of this before. This shouldn't be brand new to you, but we're going to kind of review it real fast and then perhaps present some information to you that you haven't heard before. Ultimately, the question we're going to begin with and end with is the greenhouse effect. Is it good or is it bad? And to make that call, you have to understand what it is and definitely what it is not. There's a beautiful picture of a greenhouse here. I wish I had that in my yard. I will come back to this a little bit later in the slides. Now, I'm assuming you've already seen the video that I posted on the greenhouse effect, which gives you an indication as to which elements and which molecules in the atmosphere are considered greenhouse gases. So if you haven't seen that video already, please go watch it. I posted it there through Edpuzzle. If you've seen the video, then it makes sense to ask the question, which molecules in our atmosphere are jiggly and lopsided, right? Jiggly and lopsided kind of describes me around Christmas time. The greenhouse gases in our atmosphere are listed here. This is not a complete list, but this has the main ones: water vapor, carbon dioxide, methane, ozone, and nitrous oxide. The two most abundant are right here, water vapor and carbon dioxide. Remember, carbon dioxide does not make up a huge percentage of our atmosphere, but it has a pretty big effect on the temperature when it comes to the greenhouse effect. So keep in mind, these are the elements that are either lopsided in their structure, the way that they're put together, or they can kind of vibrate and bounce around, and that allows them to absorb energy that would otherwise escape out into outer space. So they keep our planet warm. They act like a blanket that covers it. So if you have ever gone to your car after your car has been sitting in the sun for a long period of time, even if it's a cold day, if it's sunny, you'll notice essentially the greenhouse effect within your car. Light can get through your windows, which is energy, and it can heat the inside of your car. And then when that heat energy tries to leave, it has trouble leaving your car, which means on a hot day, inside your car is roughly the temperature of the surface of the sun. Okay, that's an exaggeration, but you know what I mean. This is when your leather seats and the metal buckle on your seat belt will just burn your skin, right? It's incredibly hot in there. But why? How does energy get in but have trouble getting out? That's related to what kind of energy it actually is. Energy from the sun comes to us in the form of shortwave radiation. You've probably heard of ultraviolet before. Ultraviolet light can't be seen by your eyes, but it can hit your skin, it can hit the ground, it can hit a home, and it can warm up that surface. All right? That's why the slides at the playground after baking in the sun are just not very much fun to slide down. That shortwave radiation travels through our atmosphere, and all of our greenhouse gases do not do a good job of absorbing the shortwave radiation. But when that shortwave radiation hits the surface of the Earth, it gets absorbed by the Earth, and then it leaves in the form of heat that is long-wave radiation. Look at these other arrows. Notice how the waves here, that's not what they really look like, okay, but that's just to give you an artist's rendition of what the long-wave radiation looks like. You've probably heard of infrared before. And infrared radiation also cannot be seen by our eyes, but it is heat leaving an object. It's this long-wave radiation that gets absorbed by the greenhouse gases in our atmosphere, at least in part. So this answers the question, how does the energy get through the windows? How does it get through our atmosphere? It's because it is short-wave ultraviolet radiation. But when Earth tries to give that energy back, it changes it and it releases it in the form of long-wave radiation, and that's what your windows can keep trapped within your car. And that's the type of energy that our atmosphere does a good job of keeping close to the surface of the planet. And so that's why it's different. All right? Now, that being said, is the greenhouse effect good or is it bad? As long as it's kept within control, the greenhouse effect is fantastic. Remember, the short video that you watched prior to this one showed that without the greenhouse effect, our Earth would not do a very good job of absorbing that energy from the sun. We'd be exposed to harmful rays, and it would actually be difficult for the temperature around our planet to stay at a livable temperature. It would be incredibly cold. So the greenhouse effect is good as long as we control or try to positively influence the amount of greenhouse gas in our atmosphere. If you got questions, let me know.